Hi there! This interview focuses on one of the most common and most uncomfortable decisions in production engineering: roll back or push forward. You are going to hear questions that come up in real incidents, not clean textbook scenarios. The goal here is not to say the perfect thing. The goal is to think clearly under pressure. Before you listen to any answer, pause the video and say your own answer out loud. Treat it like a real interview. If this format is useful to you, subscribe so you do not miss the next one. Warm-up behavioral questions. Tell me about a time you had to make a call in production with incomplete information. A strong answer usually starts by acknowledging that incomplete information is the norm, not the exception. I would explain that I try to stabilize first by stopping further change and limiting blast radius. Then, I focus on identifying what I know for sure, what is assumed, and what is unknown. I would talk about communicating uncertainty clearly to stakeholders so expectations are set correctly. Finally, I would describe how I made a decision that was reversible, knowing I could adjust once more data came in. Describe a situation where you disagreed with the team on how to respond to an incident. A solid response here shows calm disagreement, not stubbornness. I would explain that I laid out my reasoning clearly, including risks and trade-offs, and invited others to challenge it. If the team chose a different path, I supported it fully, while watching closely for signals that we needed to change direction. What matters is not winning the argument, but protecting users and learning afterward. How do you balance speed versus safety during an outage? A good answer sounds practical. I would say that speed matters most when users are actively impacted, but unsafe speed can make things worse. I usually aim for the fastest action that reduces risk, even if it is not the final fix. That might mean disabling a feature or rolling back traffic. Once the system is stable, I slow down and move carefully. Speed first to stop the bleeding, safety next to avoid new damage. Tell me about a time a rollback did not actually fix the problem. A strong candidate is honest here. I would explain that sometimes a rollback fails because the issue is data-related, configuration-related, or caused by an external dependency. In that case, the rollback still provided signal. It ruled out one category of causes. I would describe how we used that information to pivot quickly rather than doubling down on the wrong assumption. Core technical and scenario. Questions. Let us talk about the difference between a rollback and a forward fix. How do you decide which one to choose in production? I think about three main things. First is blast radius. If the change clearly introduced the issue and the rollback is low risk, that is often the fastest path to recovery. Second is reversibility. Some changes are not cleanly reversible, especially data migrations or schema changes. In those cases, a rollback might cause more harm. Third is confidence. If I am highly confident in the rollback outcome, I lean that way. If confidence is low, I may choose a forward fix that addresses the observed behavior without undoing unknown side effects. Imagine you deploy a change in error rates spike immediately. Metrics are clearly worse. What do you do first? The first thing I do is stop further rollout if it is still in progress. That buys time. Next, I compare current behavior to the last known good state. If the spike correlates directly with the deploy and there are no irreversible changes, I strongly consider rolling back quickly. At the same time, I assign someone to start investigating root cause so we are not blind if the rollback fails or only partially helps. Now imagine a different scenario. You deploy a change, and 30 minutes later, users report subtle issues, but metrics look mostly fine. What changes? This is where blind rollbacks get risky. Subtle issues often involve edge cases, data consistency, or performance under specific paths. I would hesitate to roll back immediately unless I have clear evidence the deploy is responsible. I would start by reproducing the issue, checking logs and traces, and narrowing the scope. If we cannot prove the deploy is the cause, a forward fix that targets the observed behavior may be safer than reverting blindly. How do database changes affect rollback decisions? Database changes are often the deciding factor. If the deploy included a destructive migration or data transformation, rolling back application code may leave the system in an inconsistent state. In those cases, I prefer forward fixes that are compatible with the new schema. This is why I strongly favor backward compatible migrations. They preserve rollback options. When that is not possible, I accept that the rollback window is effectively closed. What role does automation play in making rollbacks safer? Automation reduces hesitation. If rollbacks are tested, fast, and boring, teams use them more confidently. Automated rollbacks also reduce human error during stressful moments. However, automation does not remove judgment. You still need to know when not to roll back. The best setups combine automated rollback paths with clear guardrails and human decision-making. Imagine leadership is pressuring you to roll back immediately, but you suspect the issue is unrelated to the deploy. How do you handle that? I would acknowledge the urgency and explain my reasoning clearly and calmly. I would outline the risks of rolling back, especially if it could make things worse or hide the real problem. At the same time, I would propose an alternative action that reduces user impact quickly. That might be throttling traffic, disabling a feature, or isolating a component. The key is to show that you are not blocking action. You are choosing the safest action under uncertainty. Let us go deeper into some harder situations. Imagine you are on call, and a rollback technically works, but user behavior does not recover fully. Errors drop, but conversions or core business actions stay low. What do you do next? At that point, I treat the rollback as a stabilizing move, not a fix. It told me that the deploy was part of the problem, but not the whole story. I would start by comparing user flows before and after the rollback to see what did not revert. Often this points to cached state, background jobs, or data written during the bad deploy window. I would decide whether we need a targeted forward fix to clean up or reconcile data. The key is not declaring victory too early just because metrics look better. Consider a system where rolling back takes 15 minutes and forward fixes can be deployed in 5. How does that change your decision-making? That changes the cost model significantly. I still do not blindly favor forward fixes, but speed matters when users are actively impacted. I would ask whether the forward fix is narrowly scoped and low risk. If yes, I may prefer it to avoid a long rollback window where things stay broken. On the other hand, if the forward fix touches unfamiliar code or complex logic, I might accept the slower rollback to return to a known safe state. Time to recovery matters, but predictability matters more. Let us talk about feature flags. How do they change the rollback versus forward fix discussion? Feature flags are a middle ground that often beat both options. If the issue is tied to a flagged path, disabling the flag can reduce impact almost instantly without code changes. That gives you breathing room. After that, you can decide whether to roll back the deploy, patch forward, or leave the code in place with the flag off. The danger is flag sprawl. If flags are poorly documented or reused, toggling them can introduce new confusion during an incident. Imagine a distributed system where services are deployed independently. A rollback in one service fixes errors but causes timeouts elsewhere. What is your approach? This usually signals a contract mismatch or version skew. I would pause and map dependencies to understand which services expect what behavior. Rolling back blindly across multiple services can cascade failures. I often choose to stabilize one boundary at a time. That might mean rolling back a downstream consumer instead of the producer, or deploying a compatibility fix. The goal is to restore agreement between services, not just reduce errors in one place. How do you factor observability quality into rollback decisions? Observability quality directly affects confidence. If I have good logs, metrics, and traces, I am more comfortable with forward fixes because I can validate impact quickly. If observability is weak, rollbacks become more attractive because they reduce unknowns. In poorly observed systems, every forward fix is a gamble. That is often a signal that improving observability should be a follow-up action after the incident. Let us say you have a data corruption bug introduced by a deploy. Rolling back stops further corruption but does not fix existing bad data. How do you proceed? I separate containment from recovery. First, I ensure no more bad data is written. That might be a rollback or disabling a code path. Then I design a forward fix or remediation process to repair or compensate for corrupted data. This could involve scripts, reprocessing, or customer communication. Trying to fix data inside the rollback decision itself often leads to rushed mistakes. Slowing down after containment usually leads to better outcomes. Finally, how do you decide when not to roll back at all? I avoid rollbacks when they increase uncertainty. If the system has changed significantly since the last known good state, or if multiple unrelated deploys have happened, rolling back may reintroduce old bugs or security issues. I also avoid rollbacks when the issue is clearly environmental, like a dependency outage or infrastructure failure. In those cases, rolling back code adds noise and delays real recovery. The discipline is knowing when doing nothing is actually the safest choice. Pressure and judgment. Questions. Now let us shift into judgment calls where there is no clean answer. Imagine a production incident during peak business hours. Errors are rising, revenue is dropping, and leadership is asking for an update every few minutes. The team is split. Half want an immediate rollback. The other half believe a forward fix will resolve the issue faster. What do? In that situation, my first move is to slow the decision, not the response. I ask what we know for sure versus what we are guessing. If we can clearly tie the issue to the last change and the rollback is low risk, I will lean toward rollback to stabilize the system and buy time. If the evidence is weak or conflicting, I may choose a containment step like disabling traffic or a feature flag while we gather more signal. The mistake is letting urgency force a binary decision before we understand the blast radius. Consider this scenario. You roll back successfully, but 30 minutes later, the same symptoms return. Now the team is tired, trust is dropping, and confidence in rollbacks is shaken. What is your next move? At that point, I stop treating this as a deploy issue and reframe the incident. The rollback was a test that failed to fully explain the problem. I would communicate that clearly to the team and leadership. Then I would pivot to environmental causes, dependency changes, load patterns, or data-related issues. The worst move here is repeatedly rolling back and redeploying out of frustration. That burns time and morale without improving understanding. Here is a harder one. You know a rollback will likely fix the issue, but it will also revert a critical security patch that leadership explicitly approved earlier. What do? This is where risk comparison matters. I would assess the likelihood and impact of the security exposure versus the ongoing outage. If the outage is actively harming users and business, I may proceed with the rollback but immediately put compensating controls in place, such as limiting access or adding monitoring. I would also communicate the trade-off explicitly. Silent risk is worse than visible risk. Decisions like this should be shared, not owned by one person alone. Another scenario. A junior engineer pushes hard for a forward fix and is confident it will work, but you are not convinced. However, blocking them may hurt trust and growth. How do you handle it? I try to separate validation from authority. I would ask them to walk me through the failure mode they believe they are fixing and how we will detect success or failure quickly. If they can define a tight rollback plan for their forward fix, I may let them proceed in a controlled way. If they cannot, that tells me we are not ready. Supporting growth does not mean gambling production. It means teaching safe decision-making under pressure. Final pressure question. After the incident, metrics look fine. Users stop complaining, but the root cause is still unclear. Do you keep digging or move on? I keep digging, but I change the pace. Once the system is stable, urgency drops, but risk does not disappear. Unknown root causes have a habit of returning at worst times. I would schedule a follow-up investigation with clear time limits and goals. The goal is not perfection. It is reducing the chance of repeat failure. Knowing when to stop is important, but stopping too early is how fragile systems are born. If you are still listening, take a moment to reflect on how you personally lean under pressure. Do you default to rolling back, pushing forward, or freezing until certainty appears? These questions are not about memorizing the right answer. They are about how you think when information is incomplete and stakes are high. In real interviews and real incidents, that is what people are evaluating, whether they say it out loud or not. Pause the video and ask yourself which question made you uncomfortable. That discomfort usually points to a growth area. If this format helps you prepare for real DevOps, SRE, or platform interviews, subscribe so you do not miss the next one. Each session focuses on the kinds of decisions that actually happen in production, not just theory. Let me know in the comments which question was the hardest for you and why.